Good morning, Middle 1 students. Today we are going to revise what we have covered from the second term till the 15th of March in science. We have covered Unit 1, so that we're going to revise starting from Lesson 1, the chemical combination. We said that the known elements up till now have reached 111. They are classified into three categories: metals, non-metals, and noble gases. Let's start with metal. I need you, if you have to, the study note booklet to revise with me. Metals are elements that have in their outermost energy level less than 4 electrons. We know their properties, and we said that they are solid, and except mercury, which is the only liquid metallic element. They have metallic cluster. They are good conductors of heat and electricity, and they are malleable and ductile. Next, let's compare them with the non-metals. They are elements that have in their outermost energy level more than 4 electrons. According to their properties, non-metals have no metallic cluster. They are gases such as oxygen, and solid as sulfur and carbon, and the only liquid non-metallic element, which is bromine. Their properties are they are bad conductors of heat and electricity except graphite. They have no luster. They are not malleable or ductile. And according to their chemical properties, the metals tend to lose electrons during the chemical reaction and change into positive ion. Let's take an example like sodium Na11. When we distribute the electrons, it will be 2, 8, and 1. So it's going to lose 1 electron and change into positive ion carrying 1 positive charge. Magnesium 12 will be distributed as 2, 8, and 2, and it's going to lose 2 electrons. When it loses 2 electrons, so it will be Mg plus 2. Aluminium 13, Al13, it's going to be distributed as 2, 8, and 3. During the chemical reaction, it's going to lose 3 electrons and change into Al positive 3. If I set complete, each positive ion carries a definite number of positive charges equals to the number of the lost electrons. So let's define the positive ion. Positive ion is an atom of a metallic element that loses an electron or more. Let's talk about the non-metals. Non-metals, during the chemical reaction, they tend to gain electrons and change into negative ion. What's meant by the negative ion? It's an atom of a non-metallic element that gains an electron or more during the chemical reaction. Examples for the non-metals, like chlorine, like oxygen, and like nitrogen. Chlorine 17, so it will be distributed as 2, 8, and 7. Okay, so during the chemical reaction, it's going to gain 1 electron and change into negative ion carrying 1 negative charge. Oxygen O8, it's going to be distributed as 2 and 6. During the chemical reaction, it needs 2 extra electrons to complete it with 8, so it's going to gain 2 and change into O negative 2. Nitrogen N7, it's going to be distributed as 2 and 5, so it will gain 3 electrons and change into N negative 3. Why do they form negative ion? Because the number of negative charges becomes more than the number of positive charges. This is what we said about the metals and non-metals. The third group was noble gases. If we need to just to define them, noble gases are elements that have their outermost energy level completely filled with electrons. So they don't participate during the chemical reaction in the ordinary conditions, and also they don't form ions, so they have no ions. Examples for the noble gases, they are like helium, neon, and argon. Helium, He2, so it has 2 electrons in K, and it will be saturated because K is saturated with 2. Ne, neon, 10, it will be distributed as 2 and 8, so its outermost is filled. Ar18, 288, and it will be filled with 8 electrons. Next, we said that active elements participate in the chemical reaction to form stable molecules. How the molecules are going to be bonded together? They are going to be bonded by chemical bonds, which we studied before, and we said they are divided into 2 types. They can be ionic bond and covalent bond. Ionic bond, it's a type of chemical bond that arises between a positive ion and a negative ion. Positive ion of what? Positive ion of a metallic element. Negative ion of what? Negative ion of a non-metallic element. So it arises between metals and non-metals. According to the examples for the ionic bond, we have two examples: formation of sodium chloride molecule and formation of magnesium oxide molecule. Sodium chloride NaCl, it's formed due to the combination between sodium and chlorine. Sodium is a metal, chlorine is a non-metal. So sodium Na11 will be distributed to 8 and 1. So during the chemical reaction, as we said before, it loses one electron. So when it loses one electron, it will be Na positive. Chlorine is going to gain this lost electron and form Cl -1. So the sodium and chlorine has been turned into a positive ion of sodium and negative ion of chlorine. Positive and negative are going to be attracted together by an electric attraction, which is known as the ionic bond. So ionic bond, it's a type of chemical bond which arises as a result of the electric attraction between a positive ion and a negative ion. Positive and negative will be bonded together to form NaCl. The second example, MgO. Mg12 will be distributed as 2, 8, and 2. So it loses 2 electrons and change into Mg positive 2. Oxygen O8 will gain these 2 electrons to complete it with 8 and be O negative 2. Mg positive 2 plus O negative 2 are going to bond it together by MgOY. Because magnesium became a positive ion, oxygen became a negative ion, and electric attraction will arise between the positive and negative ion to form MgO. Let's summarize the ionic bond again. An electric attraction that arises between a positive and negative ion. The second type of bond, which is covalent bond. Covalent bond, it arises between two nonmetals due to the sharing or participating the electrons in their outermost energy level. Why do they share electrons? To complete their outermost energy level with electrons. Covalent bond is divided into three types: single, double, and triple. Why do we call it single? Because each atom shares with one electron. Double, because each atom shares with 2 electrons. Triple, because each atom shares with 3 electrons. Examples for the single covalent bond, it's like in hydrogen molecule, as each atom shares with 1, and we will represent it by H-H. Another example for the single covalent bond in water molecule, as water is formed of 2 hydrogen atoms and 1 oxygen atom. So H2O, oxygen here, it has in the outermost energy level 6 electrons. So it will share with hydrogen, with each atom will share with 1. So it will be represented as H-O-H, which means that each atom shares with 1 electron. Second type, which is double covalent bond. From its name, double, it means that each atom shares with how many electrons? With 2 electrons. So the example here in oxygen molecule. Oxygen molecule is formed of 2 oxygen atoms. So they are going to be bonded together and each atom shares with 2 electrons. Now let's remember, O8 is 2 and 6. So it needs 2 electrons to complete it with 8. So each atom will share with 2 electrons. The third example, with the same concept, with the same idea, we have triple covalent bond that arises in nitrogen molecule, as each atom shares with 3 electrons. How? Nitrogen N7, it will be distributed as 2 and 5. So it needs 3 electrons to complete its outermost energy level with 8. So each atom is going to share with 3 electrons. They will be distributed as 2 and 5. When they share the electrons, they will be completed with 8. It will be represented as N3-N. Okay? This is we made a quick look on lesson 1. Let's start in lesson 2 with the same end. We ended here by losing and gaining, sharing electrons. So the number of lost, gained, or even shared electrons is known as valency. Again, valency is the number of lost, gained, or even shared electrons by an atom during the chemical reaction. According to this, we're going to classify atoms into monovalent, divalent, trivalent, and so on. Which means monovalent, it loses 1 electron. Divalent, it loses or gains or even shared by 2 electrons. And trivalent loses, gains, or even shares by 3 electrons. Here, we're going to take some examples for some metals and non-metals. Metals here can be monovalent, divalent, and trivalent. Monovalent, why? Because their outermost energy level can contain 1, so it loses 1. Divalent, it means their outermost contains 2, so it loses 2. And the same for trivalent. Examples for the monovalent metals like lithium, potassium, sodium, silver, and copper. Examples for the divalent: calcium, magnesium, iron, lead, copper, mercury, and zinc. Okay, examples for the trivalent like aluminium, like gold, and also iron. We can conclude here and we can notice that we have 2 valences for iron and 2 valences for copper. Yes, copper can be found, or we can say complete. Some metallic elements have more than 1 valency, like dots, copper, which can be 1 or 2, which can be mono and divalent. Iron, Fe, can be 2 or 3, which means that it can be di or trivalent. Another examples for the nonmetals. Nonmetals can vary, or they vary from mono, di, tri, tetra, penta, and hexa. Examples for the monovalent nonmetals like hydrogen, okay, and like chlorine. And we can call them in family: chlorine, fluorine, bromine, iodine, and so on. Examples for the divalent, we have here oxygen, okay? If I said give reason, oxygen is a divalent element because it gains or even shares with 2 electrons. Di, so 2 electrons. Trivalent, like nitrogen and like phosphorus, N and P. Tetra, it means that their valency is 4, and the example here is carbon. Penta, which means that its valency is 5. And here we have 2 examples, phosphorus and nitrogen. Hexa, it means that the valency is 6, and we have an example here, sulfur. So we can note that nitrogen and phosphorus have more than 1 valency. Like, we can say that phosphorus can be 3 or 5. Sulfur can be 2, 4, and 6. And also nitrogen can be 3 and 5. So if I said complete, some nonmetals have more than 1 valency, such as phosphorus, that can be trivalent and penta, sulfur, that can be di, tetra, and hexa, like nitrogen, that can be trivalent and pentavalent. Now we're going to study the atomic groups. Atomic groups, they are a set of atoms joined together, behave like one atom during the chemical reaction, having their own valency, and they do not exist solely. And we said examples for the atomic groups. We have monovalent atomic groups, divalent, and trivalent. We took a lot of examples for that. For example, like hydroxide, bicarbonate, nitrate, nitrite, and ammonium. Example for the divalent: carbonate and sulfate, and the trivalent, they are like phosphate. The second part was how to write the chemical formula. What do we mean by a chemical formula? It's a set of samples or set of samples that shows the type and the number of atoms in any compound. Let's say, how can we write the chemical formula? We have the first example here, magnesium oxide. Step 1, write the name of the compound. Step 2, write the valency, or write the sample for each element below its name. Magnesium is Mg, oxide is O. Below them, write the valency. Valency of magnesium is 2, divalent, and also for oxygen 2. If they can be simplified, just simplify them. If we make them divided by 2 equals 1, crisscross, the valency, the formula will be MgO. Okay? If they don't need to be simplified, just you're going to write them as they was. So if I say sodium nitrate, valence is, the sample of sodium is Na, nitrate NO3. Another example, sodium is 1, nitrate is 1, monovalent, so crisscross or make them exchange it, so it will be NaNO3. How to write the chemical formula? We took a lot of examples for them. The next part for compounds. We have a numerous number of compounds, and we said that they are going to be classified into 4 categories. Group 1, acids; 2, bases; 3, oxides; 4, salts. Acids, they are substances that dissociate in water, giving positive hydrogen ion. Bases are substances that dissociate in water, giving negative hydroxide ions. Examples for acids that like hydrochloric acid, sulfuric acid. Examples for bases, NaOH, sodium hydroxide, or potassium hydroxide. If we talk about their properties, acids, they have a sour taste, but bases have a bitter taste and they feel slippery. According to their reaction with the litmus paper or their effect on litmus paper, acids turn it into red, bases turn it into blue. Oxides, they are formed due to the combination between oxygen and another element. So they can be metallic oxide or non-metallic. Metallic oxide, it's like Na2O, sodium oxide. Non-metallic oxide, it's like carbon dioxide. The fourth type or the last type of compounds can be salts. Salts, they are substances that are formed due to the combination between positive ion or negative ion with a negative ion or a negative atomic group. Again, positive ion or a positive atomic group with a negative ion or negative atomic groups. We have a lot of examples for them. We're going to take 2 examples, sodium chloride, silver chloride. We can say a lot of examples like sodium nitrate also, and a lot of examples. Salts can dissolve. Some salts can dissolve in water like sodium chloride, while others cannot dissolve in water like silver chloride. This is the last part for lesson 2. Lesson 3, we talk about the chemical reaction. How did the chemical reaction take place? We have the first activity or the first example, burning magnesium strip in air. We said by burning the magnesium strip, the heat energy or this heat is going to break down the double covalent bond between the 2 oxygen atoms and give me 2 active oxygen atoms. Then each one of them is going to react with a magnesium atom to form magnesium oxide. This is how to write the chemical equation. So what's meant by a chemical reaction again? It's breaking of the existing bond between atoms of the reactants and forming new bonds between atoms of the products. Why? Because here in the reactant the bond was double covalent, and in the product it became ionic bond between magnesium and oxygen. The second part with the chemical equation. How to write a chemical equation? We said that it shows us, or it's a set of samples and chemical formula that shows us the reactant molecules, here magnesium and oxygen, product molecules, which is magnesium oxide that resulted from the reaction, and also it shows me the condition of the reaction here, which is heat. Okay, so to write the chemical equation, we should write it balanced, which means that the number of atoms that enter the chemical reaction must be equal to the number of atoms in the products. Here, 2 magnesium atoms, 2 magnesium, 2 oxygen, also 2 oxygen. So this is why we say that the chemical equation should be balanced. Also, the total mass of the reactant must be equal to the total mass of the product, and this is known as the law of conservation of matter or mass. And also the ratio between the reactant must be equal to each other. So to form the magnesium oxide here, the ratio between magnesium and oxygen in the reactant must be 3:2. And this is what we said before, or to achieve the law of constant ratios. The last part in lesson 3, which is talking about the chemical reactions. We have many types of chemical reactions. The first one, which is the direct combination. Direct combination, it means like we have an element, a matter A and another matter B, they are going to combine together to form AB. Here, the first example, if I have an element with another element, and it takes place especially between nonmetals. If I have carbon and oxygen, so C plus O2, it's going to form carbon dioxide, CO2, hydrogen, H2, chlorine, Cl2, it's going to combine together to form 2HCl, hydrogen chloride. Another type for the direct combination, element plus compound. Element plus compound, here the element is oxygen, and the compound here in the first example, carbon monoxide. So if I have here carbon monoxide plus oxygen, it will form 2CO2, which means carbon dioxide. The second example, 2NO, nitrogen monoxide, it's going to react with oxygen to form 2NO2. Third type of the direct combination, like a compound plus a compound. We have here an example when ammonia gas reacts with the concentrated, this conc, it means concentrated hydrochloric acid, it will form ammonium chloride. And if we have here the test tube and we approach the ammonia gas to the hydrochloric acid, it will form white fumes. So white fumes will be formed due to the combination between ammonia and the concentrated hydrochloric acid. Okay, so again, NH3 ammonia will combine with HCl to form NH4Cl. If you just add the atoms, you're going to find that N here, 1 N, 3 hydrogen plus 1, it's 4, and the Cl. Okay, all these chemical reactions have some useful applications in our daily life and other negative effects and negative uses. The useful uses for the chemical reactions in our daily life, we can use them in many industries, such as the industry of plastic, also in making a lot of medicine, fertilizers, and so on. The negative effects for this chemical reaction, as they can produce negative gases or harmful gases, they are like the first one, oxides. We have two negative gases here, carbon monoxide and carbon dioxide. Carbon dioxide, it's known as a greenhouse gas, which it permits or it allows the sunlight to reach the earth, and it prevents its returning back, so it increases the temperature of planet Earth, which causes global warming phenomena. In the second example, carbon monoxide, also it has a lot of harmful effects, as it causes fainting and severe stomach aches. Sulfur oxides, we have sulfur dioxide, SO2 and SO3. They are acidic oxides that also have negative effects on the nervous system, and they cause a lot of negative effects. Nitrogen oxide, they are like nitric oxide, NO, and NO2, nitrogen dioxide. Also, it takes place, or they are acidic gases that are produced at the time of lightning. And the last example, burning of coal and cellulose fibers, which produced during burning of food, paper, and cigarettes, they can cause lung cancer and a lot of the respiratory system problems. I need you just to revise well, and I hope that you are fine. Good luck. Thank you.